All right, so this is a review for the test tomorrow. On the first one, you're given a table, and we want to know which of these equations would give us this table. So it's just a matter of going to y equals, putting choice A, B, C, and D in there, and see which one gives us that exact table. So did anybody find the equation that matches up with this table here? A. That is correct. If I put A into y equals, this is the table that I should in there. So that's all you had to do with number one. Number two, very similar. This time they give you the equation, and we want to know which of those graphs matches that equation. So y equals square root of x plus 4 minus 2. Which graph of that equation should be G? All right. Next one, they're asking for the domain of the function. And in order to find the domain, all we're going to do is take the part that's underneath the square root, the x plus 5. And what we're going to do is set it greater than or equal to 0. Once we've got it greater than or equal to 0, it's just a matter of solving for x, which means I need to subtract 5. 0 minus 5 would be a negative 5. Therefore, our domain is x is greater than or equal to a negative 5. So the right answer here should be C. Okay, number 3 is C. Number 4, when solving the problem, the square root of x is equal to 5. Sam squared both sides and got 25 for his answer. We want to know, is this correct? So here's what they're saying he did. He took this equation right here. He took both sides and squared it and got x was equal to a 25. The question is that right? Yes. Yes, it is. Now we got two yeses. We got F and H. Yes, negative 5 is squared. Negative 5 squared is 25. Or yes, the square root of 25 is 5. Which one should it be? Square root of 25 is 5. Okay, so that should have been H. All right, on number 5, we're solving the equation. We need to solve for x. Yep, we're going to take the equation. And I'm going to get rid of the square root. And the way we get rid of the square root is by squaring both sides of the equation. I'm going to start with the right side because it's the easiest side to square. If I square the right side, I end up with 2x minus 1. The square root and the square cancel each other out. Now we need to be real careful when I square the left side. What I'm doing is x minus 2 times x minus 2. So I'm going to have to do some FOIL here. X times x is going to give me an x squared. X times a negative 2 is a negative 2x. Negative 2 times x is a negative 2x. And a negative 2 times a negative 2 is a positive 4. So here's what I have so far. Notice how these two terms right here are like terms, so I'm going to go ahead and combine those two terms together. Negative 2x minus 2x is a negative 4x. So here's where I'm at with my equation. Now notice what we have here is a quadratic. And anytime we're working with a quadratic, we have three different ways that we've talked about to solve a quadratic. We have the graphing method, we've got factoring, and we've got quadratic form. Graphing is going to be the easiest one. But before I graph it, it's got to be equal to what? 0. So I'm going to go ahead and subtract 2 x's. Alright, so I've got x squared is equal minus 6x. Oops. Sorry about the plus 4 there. Plus 4 equals negative 1. Still trying to get it equal to 0, so now I'm going to add the 1 to the 4. So now I've got x squared minus 6x plus 5 equals 0. So now that I have it equal to 0, I'm going to go to my calculator. I'm going to graph this thing and find me the solutions to the quadratic. So everybody go to your calculator and let's graph it and find the x-intercepts. There should be 2 of them. 2 x-intercepts. 1 and 5. So the two solutions to this quadratic are 1 and 5. However, you'll notice our choices A, B, C, and D, there's only one answer. So only one of these numbers is going to work when I plug it back into the equation. So the question is, which one works? Well, let's try it out. Let me start with 1. If I replace x, both of the x's with a 1, they should be equal to each other. The two sides should be equal to each other. So this should be 1 minus 1. All right, so let's see here. 1 minus 2. 1 minus 2 would be a negative 1. Put that in your calculator. The square root of 2 times 1 minus 1. See what you get when you put that in your calculator. Let's see if we get negative 1. Square root of 2 times, and that should be a 1 right there, minus 1. It's a positive 1 or negative 1? Positive 1. As you can see, a negative 1 is not the same thing as a positive. So this is not an answer. Just to make sure, let's try the 5 also. I'm going to put the 5 in for x this time. And let's see what happens this time. 5 minus 2. 5 minus 2 would be a 3. Let's put this in the calculator and let's see what happens. The square root of 5 times 2 times 5 minus 1. And this time you get a 3. Notice how the left side equals the right side, which means 5 is our solution. So the right answer to number 5 should be choice C. C is the right answer. So make sure you check it. Even though you got the answers, one of them may not work out. Number 6 is another equation with square roots, but this time we're going to solve it by graphing. A little easier here. So what we're going to do is go to the calculator, and in y1 we're going to graph the square root of x minus 4 plus 2. That's the left side of the equation. In y2 we'll type in the right side of the equation, which is square root of x plus 4. We're going to graph both of those. And what we're going to do is we're going to find the point of intersection. We're going to ask the calculator to find where they cross that. Make sure you do it in y1 and y2. Also, be careful, guys, when you type this in, make sure that the plus 2 on that first equation is on the outside of the square root, because if it's not, you're going to end up with the wrong graph. Be real careful with that first. X plus 2. X plus square root of x minus 4 plus 2. See your graph. All right, so it looks like the graph is looking something like this here. We're finding that point of intersection. So if you look down at the bottom of your screen, the x value is what we're looking at, and that x value is what? Positive 5. Therefore, a solution to number 6 is positive 5. That's how we solve using the graphing. Just find where they intersect at. Number 7, all we're doing is graphing the inequality y is greater than or equal to 2, square root of x minus 1 minus 2. So go ahead and put that in your calculator for me. In y1, we're just typing 2, square root of x minus 1 minus 2. If you want to see the shading over here to the far left side, the greater than symbol would be this little triangle right here. That's what it's going to look like in your calculator. And what you see on your calculator is what you're going to graph for me on your paper. Now, just looking at the equation itself, I noticed that the minus 1 underneath the square root, that minus 1 is going to move the graph over to the right 1 unit. The minus 2 on the outside is going to move the graph down 2 units. I also know that 2 that's in front of the square root is going to stretch the graph out vertically. So your graph is going to look something like this right here. However, there is some shading involved. It is an inequality, so that greater than means that we should be shading to the top of our graph. So everything at the top of that graph that we just drew should be shaded. So that's the graph that we should have for number 7. That's number 7. All right, number 8, the equation for the volume of a cone is V equals 1/3 pi r squared h, What they want us to do is solve for r, and then we're going to use that equation to find the radius given a cone with a height of 12 inches and a volume of 1,005 cubic inches. So let's start by taking the equation. And the first thing we're going to do is we're going to solve it for r. I want r all by itself. First thing I'm going to do is take both sides and multiply it by a 3. That way I can get rid of that 1/3. So this 1/3 and this 3 gone. Now I have 3b is equal to pi r squared h. So this is my new equation. All I did was multiply both sides by 3. Notice what they're doing to the r squared. They're multiplying it by a pi and an h. So I'm going to do the complete opposite. I'm going to divide by that pi and the h. I'm going to do it to both sides. This, y, that, and that will cancel out. So now I've got the new equation 3v all over pi h is equal to r squared. I'm almost done. I want r by itself. So what's the opposite of squaring? Square root. So we're going to square root both sides. This way we have the r all by itself. And now we have the square root of 3b all over pi h. So there's the first part. That's the equation they want. That right there will get you partial credit. Now what we're going to do is we're going to use this equation so that we can solve for the radius. Now here's what they told us. They told us that the volume was 1,005, and they also told us that the height of the cone was 12 inches. So I'm going to put that into my calculator and see what we get. So go ahead and put that in the calculator and see what number you get. And it should be a decimal. Right here it says approximate the radius. So we're just going to get a rough estimate. All right, 8.94 cents. Make sure when you type it in, it's square root. Then to get the fraction, remember you can use the green button and then the white. Do that, and then you should get the 8.94. All right, so that's approximately what the radius would be. All right, going on number 9. Number 9, they wanted us to describe the changes on the graph when the equation is changed from the parent function y equals square root of x to y is equal to the square root of x plus 5 minus 2. So let's start with the plus 5. Yeah, 8.5. What is a plus 5 going to do to our graph? It moves it to the left 5. Okay, so right now, that already rules out a couple of choices, right? It rules out choice A, and it also rules out choice C. So it's either B or D. Moving to the left 5. What about the minus 2? What is the minus 2 going to do to the graph? Make it go down 2 units. Therefore, the correct answer here should be B. 9 is B. All right, number 10, you're asked to find the domain and range, given the equation t is equal to the square root of d over 15. The easiest way is just to go ahead and graph this. Of course, when we graph it, put it in our calculator, we don't have d, we have x. So we're going to type in the square root of x over 15. We'll graph it, and then we'll determine what the domain and range is from the graph itself. Put that in the calculator, see what we get. Well, it's not really a line because we're graphing a square root. So, graph looks something like this right here. That's the graph we're getting. So let's talk about the domain. Notice where the x's start at. They start at 0. Are the x values getting bigger than 0 or smaller than 0? Bigger than 0. They're getting greater than 0. Now remember, of course, we're not using x for the domain. We're using d. Okay, so the x's are greater than or equal to 0. So that already rules out choice F and J. So it's either G or J or H. The y values. Notice how the y values also start at 0. And because the graph is going up, those y values are getting larger as well. So the y values, or in our case, the t, is also getting greater than or equal to a 0, which means the correct answer here should be G. G would be the right answer. All right, number 11, we're asked to find the inverse of y equals the square root of 2x minus 3. What is inverse? What do they want us to do to find inverse? Switch the x. Switch the x and the y. So I'm going to change my y into the x and change the x into the y. After I do that, now it's a matter of solving for y. I want to get y by itself. So, to get y by itself, the first thing I'm going to need to do is get rid of this square root symbol. And to do that, we're going to do the opposite, which is to square it. Of course, you're going to have to square both sides. So make sure you square both sides. So now what we have is x squared is equal to 2y minus 3. I'm trying to get y by itself. So the next thing I'm going to do is move the 3. Opposite of subtracting 3 is adding 3. So now I've got x squared plus 3 is equal to 2y. Almost done. I want y by itself. So what do I need to do last to get y by itself? Divide everything by 2. Divide this side by 2 and divide this side by 2. Which means this is going to give me y equals x squared plus 3 all divided by 2. Of course, we did have a certain notation that we used for inverses, and that was this right here, f with a little negative 1. X equals x squared plus 3 all over 2. That was a notation that we used for inverses. Right. Well, remember, on the test is going to be multiple choice, so you should see one of those. It should be written down already for you. Number 12 is the same thing. We're finding inverse again. So I'm still going to go ahead and switch the x and the y. So now it's x equals 1/3 y squared plus 2. I want the y all by itself. So I'm going to come over here and subtract 2 first. So I've got x minus 2 is equal to 1/3 y squared. X minus 2 equals 1/3 y squared. Next thing I want to do is get rid of that 1/3. And the way I'm going to do that is by multiplying both sides by a 3. Now here's where I had a lot of people messing this up. I need to multiply the left side by 3, which means I'm multiplying all of this times 3. So I'm going to need to use some distributive property. 3 times x is 3x. 3 times a negative 2 is a negative 6. So now I've got 3x minus 6 is equal to y squared. I'm almost finished. I want y by itself. Right now I still got y squared. So what's the opposite of squaring? Square root. So now we're going to square root both sides, which means now I've got y is equal to square root of 3x minus 6. Of course, remember we do have that notation for inverses, which is this right here. So this is our answer. That is the inverse of y equals 1/3 x squared plus 2. Is this sounding familiar? Remember doing this? Number 13, in a hurricane, the mean sustained wind velocity, V, is given by V of P is equal to 6.3 times the square root of 1013 minus P, where P is going to be the air pressure at the center of the hurricane. They want us to estimate this air pressure at the center of the hurricane when the velocity is 52.5 meters per second. And we're going to round our answer to the nearest whole number. All right, so we're going to replace V, the velocity, with 52.5. And what we're going to be solving for is P, the pressure. There's the equation we're working. I want to know what is P equal to. Now notice it says we're going to round to the whole number, but we're not going to do that to the very end. So get your calculators ready. The first thing we're going to do is divide both sides by 6.3. That way we can cancel that out. So go to your calculators and divide that from 52.5 divided by 6.3. And it's going to be a real long decimal. 8.333. Is that right? Okay, now leave that decimal there. Don't clear it out. Leave that big decimal. What we're going to do with that big decimal is the next step. And the opposite of square root is to square. So the next thing I'm going to do is I'm going to square both sides. What I want you to do now, with that number still in there, all you need to do is hit the square button. And when you hit that square button, you should see A and S. It's going to take the answer that we just got, and it's going to square that number. So what do we got this time? 69.4444. Of course, over here, all we have is 1013 minus P. Again, keep that big number in there. The next thing we're going to do is subtract that 1013. So just hit the minus sign. And again, you should see A and S pop up. That's the answer. And we're going to subtract 1013, which is negative negative 943.556, whatever. Now notice there's negative P, which is kind of like having a negative 1 in front of that P. We need to get rid of that negative 1. So we're going to divide both sides by negative 1. And all that's going to do is change the sign on. So now we got negative, not negative, but because a negative divided by negative makes it a positive 94355. But remember, it says we're going to round to the nearest whole number. So if I were to round that to the nearest whole number, that now becomes what? 940. There we have 940. Okay, number 14. Number 14, a lookout on a submarine H feet above the surface of the water. The greatest distance in miles it can look out on a clear day is given by the square root of the quantity H multiplied by 3/2. All right, so let's go there. The distance, D, we can find by taking the square root of the quantity H multiplied by 3/2. That's 3/2 times H. So this is the equation we're going to be using. Now it gives us the distance 5 miles. A ship is 5 miles from a submarine. We want to know how high, we want to know what H is, so that we can see this submarine. All right, so here we go. We're going to replace D with 5. That's the distance. We're going to solve H high. So the first thing I'm going to do is get rid of the square roots. We're going to do that by squaring both sides. So if I square both sides, I end up with 25 is equal to 3 over 2H. Now I need to get rid of the 3/2. And the way I'm going to do that is multiply both sides by the reciprocal. Reciprocal just means take the fraction, flip it upside down. That way the 3's will cancel, the 2's will cancel. Got the h. Of course, I'm going to need to put this in my calculator. What do you get when you multiply 2/3 times 25? 2/3 times 25. 16.6666666. And there we have it. Now notice here they didn't tell us any specific place to round, so we'll go ahead and leave it 16.666. Of course, on the test it'll be multiple choice, so you should see one of the choices. Number 15 is another that's very similar. The formula P equals the square root of L over 32 divided by 32 can be used to approximate the period of a pendulum, where L is going to be the length in feet of that pendulum. If the pendulum's period is 1.5 seconds, we want to know what would be the length. And it says here we're going to round it to the nearest tenth. All right, so here we go. P, that's the period. We know it's 1.5 seconds. We're looking for L, which is the length of the pendulum. All right, so here we go. To get rid of the square root, we're going to square both sides first. So if I square 1.5, 1.5 squared is 2.25. And that's going to be equal to L over 32. I want L by itself, so since they're dividing by 32, I'll do the opposite. I'll multiply by 32. So 32 times 2.25, what is that? 72. So the length of this pendulum is 72. Now there was no decimal, so 72 is how we're going to do. Number 16, we want to know what is the horizontal asymptote for the function y equals 3x plus 5 over 2x minus 7. Now, since we're looking for the horizontal asymptote, we need to look at the degree of the numerator and then look at the degree of the denominator. So let's start over here. The degree of the numerator. What's the biggest exponent you see in the numerator? 1. Now I'm looking for the biggest exponent in the denominator. That's also going to be a 1. What we said is anytime the degrees are exactly the same, we're going to take the leading coefficients, which in our case, those leading coefficients are the 3 and the 2, and we're going to divide. So 3 divided by 2 is just 3 over 2. Therefore, our horizontal asymptote should be y equals 3 over 2. That's only if they have the same degree. Number 17, we're asked to find the removable discontinuity for y equals the not square root, but x squared minus 4x minus 12 over x squared plus x minus 42. All right, so here's what we did. First, we factored the numerator, and then we'll factor the denominator. So if I factor the numerator, to get the x squared, we're going to need to multiply x times x. That's how you get an x squared. What two numbers can I multiply together to get negative 12, but would also add up to a negative 4? Which ones? Negative 4 and 3. That would give me negative 12. However, would that add up to a negative 4? There you go. That sounds better. Negative 6, positive 2. Notice negative 6 times 2 would give us negative 12, and negative 6 plus 2 would give you a negative 4. Those are your factors for the numerator. Factors for the denominator. You know that x times x will give you x squared. What can I multiply together to get negative 42, but would also add up to a positive 1? What's that? Minus 6 and plus 7. When I multiply those two numbers, I get negative 42. When I add them up, I get a positive 1. Now here's what we said. If I take the two denominators, if I take those factors, set them equal to 0. For this first one over here, if I solve for x, I'm going to get a 6. If I solve this one over here, I'm going to get a negative 7. One of these is the vertical asymptote. The other is called the removable discontinuity. So which one is which? Anybody remember? What is this one right here? Is it the vertical asymptote or the removable discontinuity? It is the removable. This is the one we're actually looking for. How do I know that? Remember we said if they have the same factors right here, then we end up with a whole, that removable discontinuity. Whatever gives us a 0 both in the numerator and in the denominator is that removable discontinuity. This negative 7 over here actually represents our vertical asymptote. That's 17. Number 18, we want to know what's the equation of this graph here. Well, in order to find the equation of the graph, you're going to need to know the vertical and the horizontal asymptotes. A is just 1. There is no stretching or compressing here. X, what? Minus 5. That's because of this vertical asymptote. It's at negative 5. And then plus 3. That's because of this horizontal asymptote. I will get from moving the graph about 3. So there's the equation for this graph. (19). This time I give you the equation. You tell me what transformations occur. This minus 5 right here, what is it doing to the graph? Where is it moving it? To the right 5 units. What is this minus 3 doing to the graph? Moving it down 3 units. So which choice would be the right answer there? Which? D. Moving it down 3 and to the right 5. Down 3, right 5. Simplify the rational expression. We're going to factor the numerator. X times x is going to give me an x squared. What can I multiply together to get 18? That would also add up to a negative 9. 6 and 3. What kind of 6 and what kind of 3? There you go. Both of them have to be negative. Negative 6 times negative 3 is positive 18. When you add them up, you also get a negative 9. Of course, the denominator, x minus 6, cannot be factored, so we leave it as x minus 6. Now that we have everything factored, we can cancel out common factors, which means we're left with x minus 3. That's your answer. All right, oops, 21, left that one off, so let me put it here. On 21, we're asked to add these two together. Of course, before I can add, I've got to have a common denominator, and that common denominator is actually just both of these multiplied together. So, 3x plus 5 times 2x minus 1, that is our least common denominator. Now, in the first fraction over here, I'm going to have to take 4 and multiply it with something. What am I going to have to multiply it with? 2x minus 1, which I'll do in a second. Over on the other fraction, that 6x, I'm going to have to multiply it by a 3x plus 5. Whatever I do to the bottom, I got to do to the top. All right, so let's see what I get. The first fraction, if I use some distributive property, 4 times 2x is 8x. That's these two right here. 4 times a negative 1 is a negative 4. Remember, the denominator is still the same. That hasn't changed. Let's do some more distributive property over here. 6x times 3x is 18x squared. 6x times 5 is, or multiplying, 30x. The denominator is still the same. That hasn't changed. Okay, now that we have common denominators, we can go ahead and add up our like terms. So this 8x right here, I'm going to add it with this 30x over here. So 8x and 30x make what? 38x, positive 38x. I've also got 18x squared that I cannot add with anything. And I've also got this negative 4 that can't be combined with anything. And of course the denominator is still the same. 3x plus 5 over 2x minus. And there we have it. That's your answer, number 21. Alright, and the last one. We're given the equation 1 over x squared plus 5x minus 3 over x is equal to 1 over x. In order to solve the equation, I need to multiply both sides of the equation by the least common denominator. So the question is, what is the least common denominator? Well, here's how we found the least common denominator. I took each of the denominators, factored them out, which in this case would be this one right here. The others are going to just say x. So this is part of my least common denominator, but so is this one over here, x plus 1. That's what I'm going to be multiplying both sides by. This side and this side. Alright, so here we go. On the first fraction, what's going to end up happening is all of this bottom stuff is going to cancel out. So all you're going to be left with is a 1. All of this cancels out with this. But on the next fraction, the only thing that's going to cancel out is this x and this x here, which means I'm going to be multiplying the 3 times the x plus 5. And I'll do that in a minute. On the other side, we're going to cancel out this x and this x, which means I'm going to be multiplying 1 times x plus 5. And now it's just a matter of solving for x. So let's go ahead and solve for x. Use some distributive property here. I'll use some more distributive property on the other side. Over here, I'm going to go ahead and combine some like terms. 1 minus 15. 1 minus 15 would be a negative 14. Now I'm going to get x's all on the same side. Subtract that x. So negative 3x minus 1x is a negative 4x. Going to add 14. Five plus 14 is 19. Divide by negative 4. And x ends up equaling to a negative 19 over 4. So our solution to this equation is x equals negative 19 over 4. Alright, so this is what the test is going to look like tomorrow. The only difference is everything will be multiple choice.